Our final section in chapter 11, 11.5, is about area of similar figures. I'm going to try to breeze through this one pretty quickly because we've already talked about this earlier in the year when we did dilations at the very beginning of the year, and you also had learned about it previously in what is normally 8th grade math. So area of similar figures, it has to do with dilations because it's a bigger shape and a smaller shape that are similar. And if we have the ratio of shapes is A to B, remember we called that K, a scale factor, then the perimeters follow that scale factor because perimeter is one-dimensional, so the K factor affects it only once. So the ratio is just the same A to B, whereas the ratio of their areas is based on K squared. So I guess we would say A to B squared. Yeah, so here we have a figure where this is 18 and this is 10. So if we're talking about perimeter, in the diagram figure 1, ratio. Oh, so let's make up a number because I want to see this with actual numbers. So this is 1.8 to 1, right? So this is 1.8 to 1 ratio. So let's say that this side is 36 and this side is 20. That way we can actually add these up because I want us to see as a reminder, because this is something that's always a struggle, is that the K affects each of these equally. So if I did side 1 plus side 2 plus side 3 plus side 4, and then here I have K times side 1 plus K times side 2 plus K times side 3 plus K times side 4. K has affected every side equally, and I could factor it out as K times S1, S2, S3, S4. So all we've done is multiply the original perimeter by K. Each side got longer by a ratio of K. But if we multiply and we do base times height, then our scaled version is K times base times K times height. Now, since this is multiplying, I can't factor out a K, and I end up with K squared times base times height. And earlier in the year, we talked about for volume, it even goes beyond that because we have like length times width times height. And if we multiply by K, we get KL, KW, KH, and we end up with K cubed times the original volume. So whatever we scale something by, we end up with the scale factor affecting each dimension. So perimeter is one-dimensional, area is two-dimensional, and volume is three-dimensional. So the ratio of perimeters is going to be 1.8 to 1, whereas the ratio of the areas will be the square of that. So it'll be, I don't know what 1.8 squared is, whatever 18 squared is, I guess. I don't know that. 4, 6, 8, 1, 4, 0, 1, 8. I think that's right. So that would be 3.24 to 1. If 18 squared is not 324, then I'm sorry I did bad math, but you get the idea. All right, so a few examples to wrap up. We've got a regular hexagon with a side length of 8 and an area of that. The regular hexagon has a perimeter of that. Find its area. So rather than dealing with all that formula for regular polygons, finding apothem and all that, all we need to do is say that 8 to 72 is basically what K is, right? That's our scale factor. So our scale factor is 1 to 9. So our area ratio is the square of that. K squared is 1 to 81. So if our original, so we're getting bigger, right? So that's important to look at. We had 8 and we went up to 72, so I kind of reversed it, but that doesn't matter as long as you know you're getting bigger or smaller. So I'm going to take this 96 root 3 and multiply it by 81 over 1. I really don't want to do that, but whatever. 96, 81. So that's 96, and that's 8, 4, 76. So I think I did that right. 6, 7, 7, 7. Yeah, that's probably about right. So my area, and it's a precise area, so it equals 7776 root 3 square centimeters. So way, way bigger than the original. Our scale factor was like about 10 to 1, right? Like we went almost 10 times as big, but our area went more like 100 times as big because that scale factor got applied twice. So as far as looking for whether our answer is reasonable, this looks very reasonable because we added like 1 decimal place here, or order of magnitude, and 2 orders of magnitude here. Everything shifted over twice. So it seems very reasonable. Rhombus, they're similar. Area of the first one is 384. The diagonals are 24 and 18 for the second one. Okay, so now we actually do need an area formula. So area 1 is 384. Area 2 is 1/2 the product of the diagonals. We learned about that earlier. So 1/2 times 24 times 18. 24 times 18 over 2. That's a 9. That's 36, and 180 is 216. So that's our area ratio. We're going to need to square root that if we want to find the length of a side. They didn't even... Oh, okay. This one has a lot of work, actually. Okay, so 384, is that divisible by 4? Yes. I don't know what these are divisible by, so I'm just going to do 4. That would be 96 over 54. Those are still divisible. No, that's divisible by 2. So that's 48 over 27. That's divisible by 3. That's 16 over 9. Great. We ended up with perfect square numbers. I was kind of hoping we would. So square root that. Our k is going to be 4 to 3. So my diagonals are 19. Okay, so shape 1 was the bigger shape, and we want to find something about the bigger shape. So we're going to find a side length of the second one and multiply by 4/3. First of all, I'm going to sketch this because we need to find a side length. So we'll pretend that's a rhombus, everything equal. And we had the diagonals were 24 and 18. So our short diagonal is 9, and that's 12, and we know there's a right triangle here. So our side length looks like they gave us a nice 3, 4, 5 Pythagorean triple, so that's going to be 15. We have 3 times 3, 4 times 3, 5 times 3. So we have 15, and to get to the bigger shape, so that's the smaller one, to go to the big one, we need to multiply by 4 over 3. So 15 times 4/3, this simplifies to 5, so we get 20. And we're working in feet, and this is a length, so 20 feet. So this is a much harder problem than I expected here, so hopefully you're able to find your way through that one. But we used a lot of different pieces of knowledge. So we used the fact that the area was so we used area of a rhombus is d1, d2 over 2. Then we found our ratio of areas, then used our knowledge about the squared relationship of that k to find the ratio of the side lengths, and then that gave us our shape. All right, so The rest is going to be practice. I'll leave that to you. Hopefully most of these look easier than that problem that we just did. Then you've got a section review that'll get you a little practice on everything from the chapter, and part of what's in here will be your test review as well.